In this lesson, we will learn about the exponential function and understand why there is this oscillation happening in front of us. The first point is that we are talking about the exponent, not the base. This means that the x here in the exponent makes a difference if the x is present in the base, like x squared. We have seen the quadratic function before, but now we are talking about x being in the exponent. This is the first point. The second point is that the base must be positive. We cannot make the base negative, because if the base is negative, we will encounter issues. Imaginary numbers. It means, imagine the base here is, for example, -1, and here we have x over 2. So, we will find the square root of -1 and incorporate imaginary numbers, which is the second very important point. Now we move on to the third point in this lesson, which is that we have learned that the base must be positive, greater than 0. We have two cases. Either the base is between 0 and 1, or it is 1 and above. Alright, let's set the base to 1 and see what happens. We notice that the function always equals 1 because 1 raised to any number equals 1. Okay, let's see what happens when the base is, for example, 2. We observe that it results in an increase. Here we see the increase. How? A continuous increase. On the positive side of the x, whereas on the negative side we have a continuous decrease. And the exponential function always intersects with the y at 1. Always at 1, meaning no matter what the exponential function is, because any number raised to the power of 0 equals 1. Okay, why is there a continuous decrease here? Because if the exponent here, the x, is negative, then we invert it, and it all goes to the denominator. So the number that was large here will become in the denominator, so we'll say 1 divided by 2, 1 divided by 2 squared means 1 divided by 4. Next, 1 over 8, resulting in a steady decline until we hit 0. This is if the base is greater than 1. Alright, we have the last case remaining when the base is less than 1. When the base is less than 1, we observe that the function approaches 0 as the value of x increases. Why? Because when a fraction is between 0 and 1, if we multiply it by itself, it becomes smaller. For example, half times half equals a quarter, and a quarter times half equals 1/8, and so on. Notice that it gets smaller from here until it reaches 0 at the limit. Why is there an increase occurring on the negative side of the x-axis? Because x here is the base. If it is negative, what does this mean? It means you go to the place and become positive. This means that the conversation is about a division of 0.7 sx. So now the decrease that happened here will occur here in the denominator. The smaller the denominator, the greater the value of the result. Here we will say 1 divided by 0.7 if x equals -1. Here we will say 1 divided by 0.7 times 0.7, which will reduce the denominator and increase the value, and so on. That's why as we go to negative infinity, this value will increase. And then, if the base is between 0 and 1, that's why this is the behavior of the exponential function, causing this oscillation between 0 and 1. And after 1, it starts to take the second curve, and it becomes constant at 1. We notice that the base never becomes negative from 0 to 1 and then higher than 1.